All right, find the slope of the line through points -4, 3, and 6, 3. Now, I bet you guys would be a lot more comfortable if this were on a graph. -1, 2, 3, 4, +1, 2, 3. There's that point, and then we have 1, 2, 3, 4, 5, 6, 2, 3, 6, -3. You find the slope, and if this were on a graph, you guys would probably count rise over run. And just write it as a fraction. Is that correct? All right. So what is the rise from, let's call this point A, from A to B? What's the rise?
-6. Wait. Yeah, it would be -6.
From A to B is -6.
Okay, yes.
-6.
Aren't we going from a y value of 3
Yes. To -3.
to a y value of -3? Right? So we start up here, we end up down here. That is falling 6. Does that make sense? All right. The run, so numerator, it's rise over run. Our rise is -6. Our run, well, we go from an x value of -4 to an x value of 6. We ran 10. Positive 10 or -10? Positive 10. -6/10 would be our slope. Reduces to -3/5.
So I said it backwards.
Question. Can you put the negative in the numerator, denominator, both, or to the side? Check all that apply. Any other questions? All right. Can you write -3/5 like this? Can you write -3/5 like this, where I have the negative out to the side?
Yeah.
And can you write it like all three of those are equivalent? Wow, we're changing minds today. Maybe just changing minds. Take out your calculators.
Get out your calculators. So what program are we on now? Is it on the
I only did that because I had told one of them first. And they do test directions.
All right, type in -3 divided by 5. You get -0.6. Yes? Do you agree? If we type this in and we also get -0.6, then they're the same fraction. Go ahead and type it in. 3 over -5. What'd you get? -0.6. Now, what if you put a negative and then parentheses 3/5? Do you agree that's what it's telling you to do? Divide first and then make a negative? Well, what's 3 divided by 5? 0.6 and then make it negative, right? Aren't these all the same? Now, why am I doing this? I'm taking enough time to do this because your understanding of today's lesson kind of depends on this, okay? Watch up here. What if I say you're at point A and you're walking to point B? I say you're at point A and you're walking to point B and you're trying to give someone directions. How would you tell them to go? Down 3 to get from A to B, or up 3 to get from A to B? Down, right? This one describes how to get from A to B. You go down 3, you go right 6. Those are directions, correct? This one describes how to get from B to A. Is it the same slope? Yes, it's just a difference in which way you're headed. Same steepness, whether you're going uphill or downhill? Same steepness? Yes, same steepness. You understand that? Here's what we're doing today. We're finding the point on this segment that is part of the way from A to B. Maybe 3/5, maybe 3/8, maybe 2/7, I don't know. We're finding a point on that segment that's a part of the way from A to B. So it's going to be important which one of these we're considering, okay? Now, quick little review. Are you okay with looking at this equation and identifying what the slope is? Raise your hand. I'm not going to call on you. Raise your hand if you can look at that equation and tell me the slope. It's in the form. It's in that form. Okay? What's the slope? Anyone? Negative 2/3. The slope is negative 2/3 written any of those three ways. How many of you could look at this equation and tell me the slope? 1, 2, 3, 4. What do you guys think? If you're brave enough to say it out loud, go for it. Just be careful. Negative 7. Levi says no. Levi, what do you think?
You would have to put it in y because I'm exposed.
You would.
And then you would have to divide everything by 2 because it's 2 watts.
Levi, you're on your A game today.
Unlike usual.
Now it's in slope-intercept form. Now you can say the slope is 7/2. So be careful. Be careful. Don't just always look at a number and say, oh, it's the number in front of x. It has to be in slope-intercept form if you're going to do that, right? And what's the slope of the line x equals negative 6? Well, what does x equals negative 6 look like? Huh?
Line.
A line? How? What does it look like?
Vertical line at negative 6.
Tyler says that. Agree or disagree? Yeah. And some people forget, oh, is x equals negative 6? Is it horizontal or vertical? I can never remember. List points on there. What's this point? Negative 6, comma, 1. Negative 6, comma, negative 6, comma, negative 2. I don't know. What's all in common about those points? X is always equal to negative 6. And if it's horizontal, the y is always going to be equal to. If it's like this, though, if it's tilted, it has a slope. If it has a slope, we need to write it in slope-intercept form. All right, that's your review. Now, we're going to do 3 things today and 1 thing on Monday. The thing we're doing today is called partitioning a directed line segment. It sounds really confusing. Not that bad. Partitioning a directed line segment. I've gone back and forth whether I want to teach it the way the book does or the way I think is best. And these notes kind of give some of the book's explanation. I'm going to give you guys options. I'm not really picky as if you're doing the right process or able to give the right explanation, I'm okay if you do it a little bit different way. So I'm going to show you how I would do this, all right? A directed line segment AB is a segment that represents moving from point A to point B. We talked about that. You start on point A and you're given directions to move to point B. If you think of it that way, the way you write that slope matters, all right? Let's do an example. We got point A and point B. Find the coordinates of point P along the directed line segment AB so that the ratio of AP to PB is 3:2. How many of you look at that and it's like, that is just a lot of words that I don't really understand yet, right? Let me break it down for you. Watch up here. Find the coordinates of point P. So point P is, it could be here, it could be here, it could be here, it could be point, we don't know where point P is. But the ratio of AP to PAP to PB is 3:2. 3:2. What's a ratio? write a ratio like this? Can you write it like this? Correct? Now, quick little review on ratios, because I'm feeling like this might be helpful for you. I always like to make things about food. You know, when we did the bisectors, what did we cut? We cut cake or pizza in this class? Cake? Oh, cake. Cake. All right, we're gonna cut up this cake, and you and a friend are gonna share it. Well, share it. Not equally. You're gonna share it though. Okay. Let's just say Jackson and Caden are sharing this cake. All right, and here's the deal. The ratio. Sorry, Caden. Jackson gets 3 pieces for every 2 pieces you get. So I'm not saying how many pieces there are. There could be 5. There could be 10. I don't know. But whatever. You guys are gonna eat the whole cake together, by the way. Okay. Congratulations. This is exciting. 3 to 2 is the ratio. 3 to 2. Maybe Jackson gets 3 slices and Caden gets 2. Maybe Jackson, cut it up into more pieces. Jackson gets 6 slices. Caden gets 4. Guess where we're going with this? There's a ratio. Let's make it the most basic though. 3 to 2. 3 to 2 means how many pieces were there? 5 pieces. Very good. Now, good luck. Why did I pick that number? I can't draw this. 1, 2, 3. Those are equal pieces, by the way. No, that's 4. Hold on. Wouldn't the Pentagon make it back? Hold on a second. The nerd in me is doing this. Oh, just wait. 1, 2. 1, 2, 3, 4, 5. Pretend that's not there. Unless you want to envision that as the crust. That was a really nerdy way to do that, wasn't it? I apologize. It's embarrassing. All right. So let's say Jackson gets 3 slices. And Caden gets 2. All right. Do you agree there's 5 slices? Okay. So Jackson gets 3. Let's write as a fraction. 3 blank of the cake. 3/5 of the cake. Caden gets 2/5 of the cake. Okay. Why is that important? Well, if we look at the distance now, here's what I want you guys to think of. If the ratio is 3 to 2, then aren't we going to be going 3/5 of the way from A to B? The ratio of the segment's lengths are 3 to 2. So we're going 3/5 of the way. Do you understand that? Is 3/5 over halfway or less than halfway? A little over halfway. So I'm going from, this is the key part. Okay, we're going so that the ratio of AP to B. Okay, it's 3 to 2. We're going from A to B. Ready? Oh, there's about halfway. Maybe P's in here. Don't write that down yet because we don't know. I'm just showing you about where it's going to be. Everybody with me? All right. Now here's how we're going to do this. All right. The way I teach it, I'm going to be giving you a graph for these. The first thing I want you to do is find out how far horizontally you have to go from A to get to B. Well, doesn't A, and this is something you're going to be writing on your papers, okay? Isn't A at an x coordinate of 3? Isn't B at an x coordinate of 6? So how far did this object go horizontally if we went the whole way? 3. Now the tendency is to do the rise first. That's the tendency because we get used to doing rise over run. Okay, I'm going to show you in a minute why that's not the best idea here. Now from A has a y value of 2. B has a y value of 8. How much change is there up and down from 2, we're going up to 8 because, right? You're going from A to B. You want a horizontal change of 3, a vertical change of, you said 6, right? Up 6. And right 3. All right. How far are we going? 3/5 of the way. 3/5 of the way. Okay. Here's the plan. We're going to take 3/5, always up here. We're going to take 3/5 of 3, and that'll tell us how far over to go. And we know it's going to be, if this is the distance from A to B, like horizontally, we know it's going to be a little over halfway. And then we're going to look at the vertical change of 6. We're going to take 3/5 of 6, and it's going to be a little over halfway up and down. And if we go over that amount and up that amount, we'll be at P, which is where we want to end up. Does that make any sense? Say it one more time. We have our horizontal change. I'm going to go 3/5 of the horizontal change. We have our vertical change. I'm going to go 3/5 of the vertical change. And I'm going to tell the person to walk over that far and up that far, and they're going to get at the point P. Make sense? Let's do it. All right. How far are we going horizontally? What's 3/5 of 3? 9/5. Let's write it both ways, as a fraction and as a decimal, or 1.8, correct? 1 4/5, which is 1.8, I believe. All right, so on our graph, am I now here's the tricky part. Am I now at an x value of 1.8? No, I'm going 1.8 units from the x value of A, right? From 3. Aren't I going over 1.8 from 3? What's 1.8 over from 3? This way? 4.8. We already have the x value of point P. Okay, so let's wait. What's 3/5 of the vertical change? What's 3/5 of 6? 18/5, which is 3.6. Is that a y value of 3.6? No, it's up 3.6 from A. Well, A was at a height of 2. What's up 3.6? 5.6. Okay. So last step, we're going to take, and again, this is more for, I'm recording the video right now, so you guys can watch it if you want to again. This is more for that. I probably wouldn't write this step out, but I would say A started at, was it 3.2? 3.2. A started at 3, 2. So my point is going to be 3 plus 1.8. That's what we said in words. I just want to write it down. And then 2 plus our vertical change of 3.6. And so P has the coordinates of 4.8, 5.6. Let's see if that matches up with where we thought it was going to be. 4.8, 5.6. Now again, now we're back to coordinates. We're not back to how far from A am I going. We have the exact coordinates from the origin. So if I start at the origin and I go over 4.8, that's a 6. 4.8 is right here. Did I say 5.6? 5.6 is like right here. That is point P. Is it about where we thought it was? A little over halfway from A to B? Does it seem like that to you? Yeah. Did any of that make sense at all? Okay. This is a lot easier to do it graphically. if you're just given 2 points and asked to find 3/5 of the way from A to B, graph it. Don't try to do it without a graph. Don't. It's just you're just asking for a mistake to happen. All right. All right. Let's do this one. I want you to find the horizontal and vertical change and then also your ratio. What'd you get as the total ratio that you're going from A to B? 4/5. Do you guys agree? Jackson, if you get 4 pieces and Caden gets 1, you get 4/5 of that cake, right? 4/5. What'd you get for 4? Did you get 4/5 of 7? Did you guys get a horizontal change of 7? From A to B. What's 4/5 of 7? 28/5 or 5.6. Remember, when you're taking 4/5 of something, it's like multiplication. What's 4/5 of 1? 4/5? Or is it decimal? 0.8. All right, so some common mistakes I don't want you to make. Some students will be like, oh, I've had enough. I'm just going to write the point 5.6, 8 to be done with it. Now, those are how much you're changing from A to B, right? Horizontal and vertical. So now to get the point, and they call the point P. Point P, we take A's x value of 1, and we add or subtract 5.6. Add, right? These are all positive so far. And then for P's y value, we take A's y value, since we're going from A to B, and we add the vertical change. What was the vertical change? 0.8. So point P is 6.6, 3.8. Now 4/5 of the way. Man, Jackson's eating most of that cake, isn't he? 4/5 of the way. We're almost all the way from A to B. Let's see if that's the case. 6.6. Right here. 3.8. There. 6.6. 3.8. Point P is at 6.6, 3.8. two good examples for you. Okay, so here's the deal. If you go to practice these and you wait until Monday morning at 7 a.m. to try to scramble into your homework, you're going to forget this. All right? I would recommend trying to do this sometime today, if at all possible. It'll reinforce it. All right? Try to find some time today, whether it's English class, social studies, whatever. They don't matter as much. So I'm just kidding. Don't tell them that. Who's your English teacher? Bergner. He wouldn't care.
No, he would.
Bergner. Good guy. All right. Does that make sense? Does this make sense at all? Be honest with me.
Yes.
All right. Thank you. All right. We'll come back to that one if we have time. I want to make sure we get to slopes. Do you guys remember parallel lines have the same slope? I know you know that because even earlier we talked about lines that would never touch. We talked about parallel lines, but now we're going to be talking about them not just out in space, but on an XY axis. So that's the difference with today. Before we had like a cube, like even on a quiz, I gave you like a cube or a triangular prism, and I said name a pair of parallel lines. They're just out in space. Now they're on an XY axis. Well, how do we find parallel on an XY axis? We have to make sure they have the same slope. Same slope. And you guys defined slope as rise over run. Do you remember the mathematical way to calculate it if it's not on a graph?
Wasn't it like x1 minus x2
You're on the right track.
or plus?
Well, how do you find distance? How do you find change? If I say how far are 8 and 2 away from each other, you would say subtract, right? So it's going to be subtraction. Christiana, what goes in the numerator? Oh. Numerator's top.
Okay. Y1 minus Y2.
Close. We always write it as y2 minus y1. And then the denominator is? How do we remember that? Oh, well, you guys all know rise over run. Rise goes with the y's. The rise goes with the y's. In the top. So if you have 2 points and you're trying to find out, you'd have 2 points on each line. 2 points. To find the slope of that line, you're going to find out what the rise of a run is. And then you'd have 2 points on the other line, plus 2. Rise of a run, and if they have the same slope, they are parallel. Did you guys learn about perpendicular lines last year? We talked about perpendicular this year. We know they form a right angle. But on a graph, have you learned about their relationship of slope? No? Okay. Do you know the words opposite and reciprocal?
Yes.
Opposite, reciprocal.
Yes.
I don't love the way the book describes it. It has its place. I think you're going to find out that an example might go a little further to help you. So let's say this, remember M is used for slope? Let's say the slope of segment AB is 4/5, and the slope of segment CD is -5/4. These would be called opposite reciprocals. Okay, there's 2 words there. Opposite means one's positive, one's negative. Isn't 4/5 a positive number? Isn't -5/4 a negative number? Now, go back to our first slide. This can be written as that, correct? Can it be written like this? No, because a negative divided by a negative would be a positive. This would not be opposite. So if a fraction is negative when any one part of the fraction is negative. Not both parts. Any one part of the fraction is negative. So do you agree these are opposite? And reciprocal means to flip. You've heard the word reciprocate, right? If you do a nice thing for someone and they reciprocate the favor, they do it back to flip directions, right? To flip order. Let's do another example. One slope is 2/3. If we're going to make it perpendicular, then the opposite reciprocal. Any volunteers to answer that one? Olivia.
Is it -3/2?
Perfect. What if one line's slope is 1? Because what's 1? Isn't 1 really 1/1? Right, let's flip it. Still 1/1. Make it opposite, -1/1. Make sense? All right. Opposite reciprocal slopes. And that makes sense. Wouldn't the red line's slope be positive or negative? Positive. It's going up from left to right. Wouldn't the blue line's slope be negative? But they have different steepness, don't they? Because it's not just opposite, they're opposite reciprocals. All right, quick example. Are lines A and D perpendicular? Here's A. Here's D. All right, we need to find the slope, all right? My line A is in blue. I'm gonna put the slope M with a little a below it, the slope of A. And I'm gonna use the points there. The points on A are -3, 2, and 0, 3. I know I can count up 1, rise 1, run 1, 2, 3. That's nice on a graph. But you also need to be able to do it with the points, okay? So let's call this one x1, y1, x2, y2, and we're gonna do y2, 3, minus y1, 2, over x2, which is 0, minus x1, which is -3. Do you see what I did there? Do you remember distance formula, how we did an x2 minus an x1 and a y2 minus a y1? Oh, it looks pretty similar, doesn't it? What's x2 minus an x1 finding? How far left and right the point has changed. What's y2 minus y1 finding? How far up and down the point has changed. Okay? What's 3 minus 2?
1.
What's 0 minus a -3?
-3.
Oh, look, they're the same. They're the same. Let's find the slope of CD. Nope, point. Can't talk. Line D. Line D. Well, I need 2 points. This one's in purple. Oh, look, A and D intersect at -3, 2. So I'm going to call -2, 0 my x2, y2, and my -3, 2 my x1, y1. And yes, I know I can count, rise over, run, but you guys are fine at that. Let's take it up a level because you're going to need to use this slope formula the rest of your math careers. So right now we're finding the slope of line D. So I'm doing a y2 minus a y1. 0 minus 2. Good, -2. And then my x2 minus x1. Be careful. It's -2 minus a -3, which is really -2 plus 3, which is 1. When we get a slope of -2 over 1 or 5 over 1 or 1,000,000 over 1, it's just that, the numerator, right? -2 over 1. How many times is 1 going to -2? -2 is the slope of D. But if you're comparing it for opposite reciprocals, it is nice to have it as a fraction first, right? So let's compare it with this form right here. Are -2 over 1 and 1 over 3 opposite reciprocals? No. So A and D are not perpendicular. We can use that symbol also that we learned last chapter, or earlier in the chapter, not perpendicular. How would we find out for part number 2, are the lines B and C parallel? If they have the same slope, okay? Well, because of time, let's look at B right here. We could do the slope formula. Do you agree we'd go, if we just did the rise over run, we would rise 1 and run 2, both positives. So the slope of B is 1 over 2, rise over run. The slope of line C, we would rise 1, run 1, 2. Do they have the same slope?
Yeah.
Yes, therefore they are parallel. So B is parallel to C. Is B parallel to A? Why not?
That doesn't have the same slope.
A had a slope of 1/3, didn't it? And 1/3 and 1/2 are not the same. Very good. All right, last problem for today that we'll have time for. I know it's a little tricky. All right, write an equation of the line passing through the point -1, 1 that is parallel to y equals 2x minus 3. How confident are you with graphing y equals 2x minus 3? Could you identify the y-intercept? The slope is 2. You can write 2 over 1. The y-intercept is, as a point, 0, -3. Very good. 0, -3 is the y-intercept. You always plot your y-intercept first, and then you use your rise over run. So this point is 0, -3. And to get the next point on the graph, we're going to rise 2 and run 1. There is line y equals 2x minus 3. But that's not what we're asked to do. We're asked to write an equation of a line passing through the point -1, 1. Okay, where's the point -1, 1? Right there. Here's -1, 1. Parallel to that line. Well, parallel means they're going to have the same slope. So ready? I'm going to cheat here. Do you agree this purple line right now is parallel to the red line? But does it go through -1, 1? Does it now? That's the line that goes through -1, 1. They have to have the same slope. So I already know the purple line. I know some information about it. Y equals mx plus b. I have the m part. What's the m part? Same slope? 2. 2x plus, what do I really need to find? Where it crosses the y-axis. Any ideas how to do that? I'm gonna run out of time. Man, these lessons are long. I'm gonna put up the homework in just a second, but freeze. To finish this problem out, you're going to use the point -1 for x and 1 for y so that you can solve for b. And then once you have b, you're gonna plug it back in. Does that make any sense? I think you guys did that last year. Double check. All right, homework for tonight. 2 through 18 even on page 154. Again, the sooner you can start these problems, I think the more successful you will be. Have a